Hello everyone, welcome to AI Anytime channel. In this video, we are going to develop a question answering QA tool for biomedical literature search. Now we are going to leverage PubMed as a data source. PubMed is a free search engine for biomedical literatures, very famous. If you are looking to query some recent case studies, some kind of information that is already available on PubMed, for something related to healthcare mainly, you can get it from PubMed. Now we're going to use that as a data source, and LLM will act as an augmentation layer. So we'll have an LLM augmented question answering tool where you can connect with PubMed and retrieve information from that using a large language model. So as a large language model, we'll use Mixtral model. Okay, so Mixtral 8x7B, which is a mixture of expert MOE model by a French startup named Mistral AI. Now Mistral AI has created this MOEs model. Now MOEs are getting famous uh, lately because people have started creating different MOEs, mixture of experts, where these models are working in tandem, having different expertise or specializations. Now, when you talk about ATEX7B, it's important because there are those models which are working together and they all have different expertise. So depending on what query you are asking, one of the model gets triggered and it works for whatever use case or task that you are executing for. Now in this video, we're gonna build using an orchestration framework called Haystack. Okay, so thanks to Haystack team for making this notebook publicly available, where they also have a PubMed feature. So you can connect with the PubMed directly and get the information, and you can use a large language model to augment those information to retrieve a human-like response. So basically, a perplexity like a tool that we're gonna build, but that for PubMed search engine. So let me show you quickly that what we are going to build in this video. So if you look at over here, and let me wear my glasses. If you look at here, it says LLM augmented QA over PubMed search engine, and it's a Gradio application. It's a Gradio UI that we have built, and you feel free to build any other UIs as you want because the code base will be available on my GitHub repository. Now, if you look at here, I have some examples of different questions related to healthcare, medical, and whatnot. Now, if you see here, one is how are mRNA vaccines being used for cancer treatment. So once I run this, it starts processing. You can see in the right hand side, it says processing. It takes around 7 to 8 seconds. Now it's almost, it's going a bit up because it acts as a, you can see now, around 12 seconds we got our response. It says the use of mRNA vaccines for cancer treatment is a promising area of research. Now, if you are working as a research, a research fellow, or if you are working as a in a hospital or in a healthcare institution where you have to retrieve information, have to go through different case studies, do a lot of research. So you can use PubMed. So people use PubMed for that, but how you can use a large language model that augments that search that you use. Now, this is what we are doing here. Now, these vaccines work by introducing mRNA into the body, which instructs cell to produce specific proteins that can trigger an immune response and blah blah blah. Right? It gives you the answer in very detailed manner over here. Now you can do a lot of post processing, which I haven't done here. For example, if you look at it, does not stop, so you can do a post processing to handle those things. But this is what we are going to build. Let me make it a bigger so you can read it as well. Now, if you see this is the output that we have got by asking this question. Now, let me just clear this. Now, once I clear this, I'll make it let me ask the other questions. I'm gonna ask, suggest me some case studies related to pneumonia. Now, I'm asking this question. What it does, goes to PubMed, fetches the relevant information, and I'll show you that how it might be fetching it once we write the code, through different keywords and the prompt template that we will define. It connect with the PubMed, and we'll use a PubMed fetcher by Haystack library, which is an orchestration framework, alternatives of LangChain, Llama Index, Semantic Kernel, and some of the others as well. Now, Haystack have created this PubMed feature. Based on your query, it goes to PubMed, fetches the retrieved information, paragraphs, context, similar paragraphs, whatever you call it, a plethora of information, and then that passed to a large language model that basically synthesize the response to retrieve the human-like response that you see currently on the screen. You can see it says it gives you a case study. I've asked for case study related to pneumonia, and it says the study aimed to investigate the association between the use of antibiotics in the first year of the life and the risk of developing asthma in childhood. And it gives you a detailed information about that. So perfect. Now this is what we're gonna build in this video, guys. To start building this, let me just submit. Now, to start building this, you need a few things. You need a Hugging Face API, because you can also maybe download locally and use as if you have the compute power. But I'm going to use the MOEs model, which requires high compute. So I'm going to use Hugging Face token from my Hugging Face repository, and I'm going to use the LLM from Hugging Face directly. Now, that's the one thing that you need. The other thing that you need is to you have to install a lot of libraries. So let's see for that answer, and then we'll go and start developing this application locally. So let's wait for this and see what it responds. And you can see it has given you the answer: significant morbidity and mortality worldwide, blah blah blah. And it has given you that how you can first identify, how you can treat as well. RT lamp has been shown to a sensitive of whatever diagnostic station, a lot of things that is happening. So basically, it basically augments you in your research and discovery if you are trying to retrieve anything from the PubMed search engine. So let's start developing this application, guys. All right, so to develop this application, I'm going to use VS Code, and you can see that I have a folder, and I'm going to open in terminal and activate my environment. So I already have a virtual environment. I'll show you what are the things that you need to install, and then we'll be set to work with this. Now let me just do a couple of cd dot dot clean. If you don't want to watch the video, you can directly go to the code, but I will recommend you watch the video where I can give you some tips as well when I'm writing the code. Now, healthcare chatbot. Let's open that in VS Code. I'll minimize this thingy. Now we are going to use Haystack, guys. So to use Haystack, you can see this is Haystack by DeepState. I'm a huge fan of Haystack and the entire community. They have done a great job, and they also have come up with the new library called Haystack AI, okay, which is like Haystack 2.0. Now, I have used Haystack when it was like pretty old. Once they started, they had extractive, summarization, extractive QA and whatnot, where we before chat gpt era, you can say that, where we were used to rely on the bot based model. So I am a huge fan of Haystack. Now, Haystack is like a very competitive alternative of LangChain, because they say that they are production ready. So if you want to develop a new skill, I will recommend you that you can develop your skills in the area of Haystack. You can work with the Haystack, and you can do the pretty much same thing that you do with LangChain and Llama Index. Now, choice is yours. Now, so here the Haystack is. I'll give the link in description. You can go through their documentations, tutorials, and they have a great community as well. And most of my codes will be from their official blogs. Okay, but I also have made some changes and the application that we're gonna build. So now let's go. Let's jump in and start writing the code. So I'm going to create an app.py, and you need a Hugging Face token. So if I can show you, I have these numbers here that you see. There are four tokens that I already have. You can have your own tokens, of course, and you have read and write access when it comes to access tokens on Hugging Face. Write is something when you push a data set or you push a model to Hugging Face Hub. That's why you need a write, but for downloading the model, you just only need the read access. So just get it from there. Now the first thing I'm going to do is import. So I already have imported, but before import, let me show you. These are the things that you need. You need Haystack AI, because that's their new library. Then you need PyMade. So you have PyMade. Then you need Gradio, which will help you develop the web UI. And then in the .env, because I have saved my secrets in env. And then you need transformers. Now let's come here and let me show you. I'll go to my other gist as well. So let me just open my your gist, because I want to save some time. So I'll just take some of the imports from here. I already have created handy, and let's come back and paste it here. Now if you look at what we are doing, we are saying from PubMed import the PubMed. So the PubMed is available in that particular library. Now we are using Haystack, the components, the document. I'll explain that once we reach there. Now components generator, we're going to use Hugging Face TZI generator. That within that we're going to use the Mixtral MOEs model 8x7B through TZI text generation interface if you don't know that. So text generation that we're going to use from Hugging Face, and then we have pipeline from Hugging Face because Haystack, excuse me, sorry. The way you use chains in LangChain, here you use pipeline, and I feel that's a better way in productions. You can look at the way that Haystack provides through a pipeline where you run things sequentially. You can also do that. Now that's the beauty of Haystack. Now you have prompt builder that helps you with the prompt. You have prompt template in LangChain, so very much similar what we do with LangChain as well. Now what I'm going to do is load.env because we're going to load our env key. So let's do os.invan. Okay, so os.invan, and the way you define, so I have defined Hugging Face underscore API underscore key, and then, excuse me, I don't know why it became small, API key, and then just do os.getEnv. So let me just do os.getEnv. So os.getEnv, and then you just pass this in parenthesis. You are set to load your API key. Now, you can also use the same code base locally as well. You have to download the model files from the Hugging Face repository wherever you use the model. You can also use the block model. For that you can use the Python llama cpp, or you can also use C transformer. Now the choice is yours. If you have the compute power, please go ahead and do that. Now here, just for the capability, I've been using directly from Hugging Face. Now os.invan is done. The next thing is we're going to connect with the PubMed. So let me just do that. So what I'm going to do is PubMed equals, and I'm going to use PubMed class that we have here, and we also imported there. Now it takes couple of params. One is tool, the other is email. Now tool is important, and email can be a dummy email. So let's see that. So I'm going to write tool, and here it's a tool where it's a string, so you can give that string. So I'm going to write Haystack. That's what they suggest. They say, okay, Haystack 2.0, and then you write prototype. So you can write that Haystack 2.0 prototype, basically a string value. And now in the email, you can also give a dummy email. So let me just write dummy email @gmail.com. Now I have my PubMed ready with this. Now I'm going to write a function for document. So let me just get the doc. We're going to do a documentization. So let me just do define documentize, and here I'm going to pass my article. So let me just pass the article here, and in article I'm going to write here in article, let's do return document, and that's why we have imported document on line number 4 if you see. And here I'm going to write content equals article dot, I'm going to get the abstract from this article. So you're going to write abstract. You can see it's right, abstract, and then a metadata kind of a thing. So the meta tags. Now for the meta tags, I'm going to have a title. So it's a key value pair. So let me just write title, and then you title write article dot title, and then you write keywords, article dot keywords. Fantastic. We are done with our first function, guys, which is define documentize. Now I'm going to create a component. So in Haystack, these are the terminologies that you have to learn. If you want to learn more, I will recommend that watch my previous videos. I have a lot of videos on Haystack, different RAG pipelines in Haystack. I created a video when there was no library like Haystack AI. I created a video where using Llama 2. I remember that. And there was no support officially by Haystack, but I did it through some of the custom based models. They have, node modules and stuff. So you can watch that video. I'll give you the link in description. Now, define documentize article. Now the next is create a component. So it's like you define like a decorator. So let me just do a component here, and now I'm going to write the PubMed feature. So let me just do pub, and this is where you write PubMed feature. So let me just do that, and let me see if I have. Let me go back to all my gist. I like to see if I have that class just to save some time. Otherwise, I have to write that. Okay, it seems like I don't have, but it's okay. Now let's come back here. Now PubMed feature. The first thing that I'm going to do is I'm going to define the output type. So I need a, so how I can do that is component dot output. You can see this is right. Output times, excuse me. I'm so sorry. Output types, and then passing the articles, and articles equals, and then I'm going to write list, and inside list, I'm going to pass document. Now this is how you define, but it's a list, so this should not be, excuse me, this is wrong. Now list and document. Now this is the articles list document. Now once you have that, let's write a function called run. So define run, and inside this function I'm going to pass self queries. Once you have self queries, let's pass list string. So let me just do that. Self queries, excuse me. And now inside this function, I'm going to write the clean query. So let me just do a clean underscore query, a variable. Now clean queries equals queries. And then when I split that, so split, not split, strip, clean query strip. And then when I strip that and then split with the line break. So strip is a function. So strip, and then I'm going to do a split. This is correct. A split. This is now okay. Now we have this. Now I'm going to define the article, which is going to be an empty list. So let me just get the articles empty list over here, and we're going to append that later. So let's have a try catch. So if try works, it's fine. Otherwise, the query is not able to get any kind of article from PubMed. So let's have a try catch. Not try catch. I'm not talking about Java here. Try except try, and for query in cleaned queries, and if the query is cleaned, then have a response from PubMed. So response equals PubMed.query, and PubMed has a query function that you can see. Inside this query, I'm going to write query and then max result. So max result equals 1. Now this is what I'm going to write in response. Now we have the response. So let's have a document. So documents equals. Now in the documents, I'm going to write documentize the function, and that in function, I'm going to pass my article. So article, for article in response. This is not response or document, only response, and this should work. Documentize article for article in response, and then articles dot extend. So let me just use the extend function and pass the documents. We are okay with this. Try now. Let's have an exception. So except, yes, correct. I think it was right. That was showing me except exception as E, and then I'm gonna print the error here. So let's print error and mainly the exception, and then I'm gonna write here manually. So F couldn't could not fetch articles for, let's write queries then, because we have queries, and to, and then just pass the queries here, and I think we are okay now. Except is done, and just get the result. So the try and the except and then result. So results equals, you're gonna pass your, it's a key value. So let's have your all of your articles, and then just return the result, and we are okay with our PubMed feature component. So this is the component that we have created, guys, the PubMed feature component. Now we're gonna use that later. Let me just, this is surprising. I will just return result. I will just close the VS Code and I will start again. Code dot. Fine. And then we write result equals, and then in the result, I'm going to write articles, and then you write articles equals articles. And then you just write, going to write return result. Now this function is done. This function is ready. We have a component that we are working with. Now I'm going to have a keyword LLM. So keyword LLM, and I'm gonna use Hugging Face TGI generator. Now inside this, you're gonna pass the Mistral AI. So let's come here and show you. Now Mistral AI Hugging Face. If you write this, come here on Mistral. Okay, now you can open. You can see they have a lot of 5 models over here, and 8x7B instruct. This is the model that we need. So Mistral has 5 models. They also have released proprietary models. So they also are going commercial. So there is nothing wrong in that. Now if you copy, find the keyword LLM. This is the model that we're going to use, okay, in this video. 8x7B instruct models, which is further fine-tuned on the instruction data set on the pre-trained fine-tuned model. Let's have a wrap warm up. So it has a warm up function. So I'm going to use warm up function. Now this looks nice. Now the next is LLM. This is for keyword. Again, they're going to define it same. And let's copy this entire thing. So I'll tell you why we are doing it twice. One is for keyword. Maybe for keyword you can use a smaller model, but I'm going to rely on the same one. You can also use keyword to extract keyword from the articles. That's also be a good approach. I just thought of it. LLM warm up. Now we need 2 prompts. Let me just show you the prompts here. So let me just come back on my gist and let me come back here on the prompts. Go to raw. Earlier we have seen this, and now I'm going to paste it here. Now once you paste this, it shows you keyword prompt template and alt G so you can read it. If you read this, it says your task is to convert the following questions into 3 keywords. So when you ask a question, it basically gets the 3 keywords. It will help you search PubMed, so the keyword based search on PubMed. 3 keywords that can be used to find relevant medical research papers on PubMed. Here's an example. What are the latest treatment for major depressive disorder? So the keywords can be, antidepressive agents, depressive disorder, major treatment, blah blah blah. And this is basically has been created by the large language model because you need that capability to infer the query and then create 3 keywords. That's what we are doing here. And the question, and then this prompt returns the keyword. Now the next is our main prompt template that goes to LLM for the output. It says answer the question. So you can read that. Answer the question. Excuse me, I'll just see my monitor. Okay. It says it is answer the question truthfully based on given documents. If the questions don't contain an answer, use your existing knowledge base. So if it's not available on PubMed, so the model still has, 8x7B, it has their own uh, eigen vectors, right? It's their own knowledge base contains in different vectors. So it has your own knowledge base that you can retrieve the information from. So it passed the questions, then you have your articles, and in the articles, what we are saying, for article in articles, content, keyword, title, meta, because we have defined that. If you look at on the documentize as well, the title, the keywords and whatnot. So these are the 2 prompts that we have. The next thing that we're going to do is create a keyword prompt builder. So we're going to use the prompt builder. So for the first, let's do keyword prompt underscore builder thingy over here. So builder equals, and I'm going to write prompt builder. And inside the prompt builder, I'm going to pass my template. So template equals, what was that? Prompt template or whatever. We are done with keyword prompt builder. The same goes for our prompt builder, which is for LLM. So let's write prompt builder equals, and then again the same prompt builder. And this time it will not be keyword prompt builder. It will be only template equals to prompt template. So let me just write prompt template. And we have our prompt builder now. Now, once you have the prompt builder, let's use the fetcher. So I'm going to write fetcher, a variable, and then I'm going to use the fetcher here, PubMed fetcher component. So let's use the PubMed fetcher. Now we get the fetcher here. Now once you have the fetcher, let's create a pipeline. So what happens is you use the pipeline, keep adding components in those pipeline. So basically it's very scalable as well. You can use Haystack to scale your LLM powered application in production as well, because it follows a very traditional way we used to work with deep learning and machine learning, our systems earlier, through a very scalable approach through pipelines. Now I'm going to use pipeline here. So pipe equals pipeline. So let me just write pipeline, and it's a class. So I'm just calling the pipeline class. Now let me just call this. Now I'm going to keep on adding components first. It also has component, also has node connectors and whatnot. So let's see. The first is pipe dot add component, and you can see the first thing that is, you can also, there are 2 things you can do. You can only just write, if you can also give a bit of naming documentation. You can just name that component, so it will be easier for other people who are reading your code. So for example, add component, I'm going to write here keyword prompt builder. So you can just write that, and you can keyword prompt builder, and then you can just write keyword prompt builder. So this is how you define a component. So pipe dot add component, and I'm gonna write keyword LLM. So keyword LLM, and then you can just write keyword LLM. So let's write that. Then I'm gonna write add component, and here in add component I'm gonna write PubMed feature. So once you give that, the next thing is that your feature will be completely in a sequential order that you see. First is that you put it basically gets the keyword, then is the get the PubMed feature, and then it gives the prompt builder in the prompt template, and then it executes the LLM for the answer. That's what we are doing. So PubMed feature, I'm gonna write feature here. So let's do feature, and then again pipe dot add component, and the next thing is your prompt builder. So let's just write prompt underscore, excuse me, prompt underscore builder, and then you define your prompt builder over here. So prompt builder, and then what next? LLM. So pipe dot add component, and then you write LLM. Now this is what it is. Now let's do pipe dot connect. So I'm gonna write connect, and the connection is, how do we connect first? So let's see. We have our keyword underscore prompt builder. So keyword underscore prompt builder, and then the prompt. So dot prompt, and then you connect this with the LLM prompt. So let me just write keyword underscore LLM dot prompt. That's the first connect. Now pipe dot connect, and then I'm gonna write keyword LLM. They'll get the replies. So let's just get keyword underscore LLM dot replies, and then this with LLM replies, keyword LLM. That is done. No, the next would be PubMed feature. So the next would be PubMed feature dot query. So PubMed underscore feature, and I hope I am spelling it right, queries. Otherwise, it will throw an error. Pipe dot connect. The next is pipe dot connect, and inside this, I'm gonna write PubMed will fetch the articles. So PubMed underscore fetch dot articles, and then this goes with prompt underscore builder. Then once you have the article, you pass that in the builder, prompt builder with the articles. So articles, and then you just again do pipe dot connect, and then here you just do prompt builder dot prompt, prompt builder dot prompt, and then this pass with LLM prompt, and then you will get your output LLM prompt, and we are done with our connection. Now let's write a function that will basically gives you, let me see if I have that function. I'm not sure, I have to go back. So we have the import, we have the questions, we have the prompts. We don't have that. Okay, now let's write that. So I'm going to write a function here called ask. So in this function, I'm going to pass my question, and you pass a question here. So the outputs would be pipe dot run, and inside this run, I'm going to write data equals, and you write keyword underscore prompt underscore builder, and here you define that question, and then you define question here. So this is what it goes. Output question, we have keyword prompt builder question. Now this should be now the next should be prompt builder. So let's just do a prompt underscore builder, and in prompt builder I'm gonna again pass my question, and then question, and then goes your question again. Now this is cool. Now the next thing is LLM. So LLM, and in LLM also again key value pair, which is generation quarks. You can just define a lot of quarks here, tokens and whatnot, temperature stuffs. Now I'm gonna define generation quarks, and then inside this again you're gonna pass. I'm gonna write to max new tokens as one. If you are using OpenAI, you just have to do max tokens, not new word. Okay, and then you're gonna let's keep it 500. And then I think we are done with this. Now this is my output variable that gives me the output. So let's print that. Okay, so print question, and then print output. So if you print output, it will give you a raw content. So I know how you can pass that. So LLM and then replies and then the first one. So let's just also return that. So return, and I'm just going to copy it from here to here. If you are going to call the function, excuse me. You can also track in terminal. That's why we have printed it to see if that works. Otherwise, it might give some error. Now, once you write that, the next thing that you're gonna do is the Gradio thingy. So let's write the Gradio thing. Now for the Gradio, it's easy. So I'm gonna use the Gradio chatbot interface. So I'm gonna write iFace, and we have GR from Gradio, and I'm gonna use the interface. So you can see it has an interface come down. It will see a class interface. I'm just gonna use that because it's easier to create a chatbot with this, which takes a function. So fn equals ask, because that's our function name, and then inputs. So my inputs are nothing but a text box. So let's define a text box. So gr.text box. You can also give a text area, but I'm going to give text box. Again, inside the text box, you can do a value like a placeholder. So value equals, and I'm going to write like, for example, uh, how are mRNA vaccines are like vaccines being used for the cancer treatments. Now this is my question as a like it's a value, it's a placeholder. Now once you write the output, the next thing we're going to do is what is should be your output. So I'm going to keep markdown as my output. So let's have a format defined for that. So markdown, outputs markdown, and excuse me, and then you give title of that. Okay, so title should be LLM augmented, Q and A over PubMed search engine, something like this. Now you have your title. Let's give a description. So I'm going to give description equals, and in description I'm going to write ask a question about the about biomedical literature. Now I think this is fine. You can customize it. The code will be available. Now you're going to give examples. I already have created some examples just to save some time. I don't want to write a lot of things. Now these are the questions of examples. Let's go raw. Control A, Control C, come over here, paste that. I'm gonna have my examples, and hopefully this is correct. Okay, let me just come back and to okay, cool. Now we have that done. Now I'm gonna have my theme. So theme equals, and let's use the soft theme. So Gradio has base, default, monochrome, color, soft, a lot of different types of themes that you can use it. So I'm gonna use gr dot themes dot soft. I'm going to use the soft theme. So it's a class that you can see. It's a soft that we use, and it gives you the color like blue and all some soft colors and stuff. Now I'm going to use allow flagging. So I'm going to keep allow flagging equals never for now. Okay. And we are okay, I think. Now let's launch that. So iface dot launch. And you can, if you are, you can also do share equals to true. If you want to get a link, I'm just going to do debug equals true. So debug equals true if I'm going to getting any error. Now we are okay with our code, guys. This is what we did. We built a quickly an app using PubMed, Haystack, PubMed, Mixtral 8x7B, and that's what we use to build this. Now let's run this and see, if this works. Let me open terminal and run python app.py. Once I do python app.py, I'm expecting that it will open a Gradio app. You can see it says running on local URL 7860. Now, let me open this in a new window, and I'm gonna just copy, maybe just copy this here. So let's copy this to come here, paste, and you can see, let me make it a bit smaller because last time I made it like you can see this is what we have built. Uh, LLM augmented QA over PubMed search engine. That's what I shown you in the beginning also. Now, you're gonna ask a lot of questions. I'm asking about tell me about HIV/AIDS, for example. I'm not a guy who have domain expertise in this field, but maybe if you are a domain expert in biomedical literature, if you are a doctor or you are a medical practitioner or a research fellow, you will be something that you need this kind of system or tool to work with, where you have to retrieve a lot of information, discover a lot of new information which is available on PubMed, or different other sources like PubMed, the Google Scholar and whatnot, right? So maybe this will help you. Now, you can see it says HIV remains a leading cause of death for adolescents and young people aged 10 to 24 years. HIV prevention requires multi-sectoral approaches, which is fantastic. I loved it. Target adolescents and young people. Addressing HIV interventions combine economic strengthening, health capabilities, and gender equality education. Best practices are unknown because evidence on multi-sectoral programming targeted. So you got some response, which is fantastic, a very detailed response because we have a max new tokens as 500. Now this is one question. Let me ask about some other questions on autoimmune disorders. Now I'm asking one more question just to show you that how it works. If probably you can improve it further because uh, maybe this can be improved further. I feel through better keyword extractions. Might be right now it's a very naive way of extracting keyword and passing it as a prompt builder, but maybe that's something on you if you are playing with it. Now, but this works fine. You can see it gives you a case study. I think it's case report of a patient who because I've asked a case study. If you look at the question, let me make it a bit bigger. If you look at, I asked suggest some case studies related to autoimmune disorders, and it gives you. It says the article describes a case report. So it gives you a case studies with a rare autoimmune disorder called IgG4 related disease. The patient was a 62 years old man who presented with chronic sclerosing. It's very difficult to pronunciate. I don't know how to pronunciate these medical terminologies, but something called dacroadentitis or something. Adenitis is a condition characterized by swelling of the lacrimal gland. I can pronunciate this one. Condition characterized by some area in lacrimal gland where there is a swelling. There's basically an autoimmune disorder called IgG4. The patient went under a biopsy, which confirmed the diagnosis. He was treated with a combination of corticosteroids and wow, this is fantastic, right? It gives you a hint because if you are struggling to see how you can at least get started to start a treatment of your patient on this kind of disease, you can get some previous case studies or recent case studies. So this is what I wanted to build, guys, in this video. Thanks to the creators of Haystack uh, for doing all the amazing job. Please give, and I'll give all the credits to them. And if you want to learn Haystack, please follow the documentations, blogs, the community, the GitHub of Haystack, and you will get a lot of tutorials, articles, and blogs on Haystack to work with these cool applications. The code will be available on my GitHub repository. Just go ahead, fork that or download it and see if that works in your machine. If you have any thoughts, questions, or feedbacks, please let me know in the comment box. I'll be more than happy to help. You can also reach out to me through my social media channel. Find those information on channels banner and channels about us. If you like the video, please hit the like icon. And if you haven't subscribed the channel yet, please do subscribe the channel and share the video and channel with your friends and to peer. Thank you so much for watching. See you in the next one.